Okay. From this slideshow. From current slide. Okay. Sorry, everything is taking forever this morning. All right. Looks like it's working well, but in order for you people to see it on Screencast-O-Matic, you have a very small screen. You have a big screen. This has a small screen. And I've got to hide this view and then do 3 more keystrokes. And it responds. Finally, we're here. All right, no questions on what we've done so far. All right, so why do we do factoring? Just a math exercise to give you something else to do? No, it's how we go about solving equations. That's the whole purpose of math, to solve problems. Okay? One reason factoring is an important algebraic skill is it extends our techniques for solving equations. Each time we examine a factoring technique, we will then use it to solve certain types of equations. We need another properties of equality before we consider some equations for which the highest common factor technique is useful. Greatest common factor, highest common factor. Suppose the product of 2 numbers is 0. Okay? 2 numbers. We have a number here, multiply them together, you get 0. What can you tell me about those numbers? One of them's got to be a 0. Can anyone give me a product of 2 numbers equals 0 and one of them's not 0? You can't do it. Okay? So, can we conclude that at least one of those numbers itself is 0? Absolutely. Okay? Let's state a property that formalizes. Property 3.5 right down here, along with the highest common factor pattern, provides us another technique for solving equations. So this is now using letters to represent numbers or expressions, or just about anything else. Let A and B be real numbers or expressions. I don't know why they say numbers. That's fine. It's true. A times B equals 0 if and only if. There can't be any other way. Either A is 0 or B is 0. One or the other. That's for numbers. It's also for expressions. We will use that repeatedly. Okay? So let's do this. Solve that equation. Now, what do we mean by solving an equation? How is that different from simplifying an expression? Simplifying an expression might mean factoring or things such as that, and canceling things out, dividing things out, whatever. That's simplifying. Your answer is still going to have the variables in it. Okay? Solving an equation. By the way, an expression is just some combination of adding, subtracting, multiplying, dividing numbers and variables. That's an expression. What makes an equation an equation? Equation. Equal sign. If you got an equal sign, it's an equation. If you don't, it's an expression. The expression you can factor or simplify, the equation you can solve. So what do we mean by solving an equation? Your answer there will be x equal 15, negative 3, 4/3, whatever. That's solving an equation. Simplifying an expression, you come up with x plus 3 times x plus 2 or something like that. You'll have still the variables in it. Okay, so how would you go about solving that equation? Second? Okay, factor out an x. Let me get my pen activated. Oh, this is such a pain. Okay. And what happens if I factor out an x? What do I have left? X plus 6 equal 0. Right? This is the same as that. Now, what does this represent? One thing, one entity, multiplied by another. What did that previous property just tell us? Say again? Okay. Okay. Okay, what did the previous property, 3.5, whatever it was, what did it just tell us? If we have a product of two entities equals 0, one of those has got to be 0. Now, what are our two entities here? Either x is equal to 0 or x plus 6 is equal to 0. Yeah, you're already solving it, aren't you? Okay? You know how to do this. Here's a solution right there. X equals 0. And you've already done it there. Subtract 6 from both sides. And that gives you x plus 6 minus 6 is 0 is equal to negative 6. There's another solution. Okay? Now, I'm really anal retentive about wanting to be right all the time. That's my wife. But, you know, I'm not. Okay, but let's see if this works. What if you plug the 0 in here? What's 0 squared? Plus 6 times 0? 0 plus 0? 0. Yes, that works. How about this one? Plug a negative 6 in there. What's negative 6 squared? Say again? 36. Plus 6 times the negative 6 is negative 36. 36 minus 36. Sure enough, that's 0 too. Yes, both of those solutions work. Okay? Now, I've done it this way. Unfortunately, I've got to erase this ink because they're going to show you how they did it. And it's exactly the same thing. They wrote it down again. What a good step, okay? And then they factored it. And then they said, by the zero product principle, that's what it's called, x equals 0, or x plus 6 equals 0. The first is x equals 0, and then subtract 6 from both sides, x equals negative 6. Same way we did. Both 6 and negative 6 will satisfy. We showed it did satisfy the original equation solution set. Now, they love doing solution sets. And you can do the set of negative 6 and 0, close it. The curly Q's here, which are called braces, braces represent a set. And yet, typically in the back of your book, when you see the answers, they'll give them in set notation. Do I care whether you put it in set notation or not? Not really. If you have this and that, that's an answer, okay? Now, if we were using some of those packages like WebAssign and stuff like this, they want it a certain way. If you don't have it that way, they'll say the answer is wrong, even though the answer is perfectly correct. So I don't like using those packages if you haven't picked up on that yet. Any questions? All right, that was example 5. Now, sorry about that. Example 5 on the slide set is example 8 in our text, okay? The slide set is the previous edition. I don't have the DVD for the current thing, but most of it's the same. They're skipping example 9, so let's do example 9, okay? What I'll do here is go to a white screen. Yuck. All right. All right, good. All right. Solve this. A squared is equal to 11a. All right. How in the world can you solve that? Ah, very good. Why would you want to do that? To make it what? Equals 0. That's the key. You want to set, now let me go over this a minute. Remember those linear equations like we had on the last one? X plus 6 is equal to 0. You don't, what you want to do there is isolate the x. Now what do I mean by a linear equation? Exponent equal to 1 and only 1, okay? This is not a linear equation because the maximum exponent here is a 2. So anytime you have a quadratic, that's what we call this, or a higher order equation, then you do exactly what she described. You want to get everything on one side, the other side equal to 0. So how do you make that happen? Subtract 11a from both sides. Okay, and what does that give us? A squared minus 11a is equal to
0. You got it. Now what do we do? Factor out the a. And that leaves us with a minus 11, and that's equal to 0. What do we have here? A product. And either a is equal to 0 or a is equal to positive 11. For those people who aren't as familiar with this, the long answer is a minus 11 equals 0. Now that's a linear equation, so now we solve for a, and we add 11 to both sides, and that gives you a is equal to minus 11 plus 11 is 0 is equal to 11. Those are our two solutions. Let's plug them in and see if they work. If you plug a 0 in for a, what do you get? Equal 0. Okay, that works. If you plug 11 in here, what do you get? 11 squared. Okay, you don't have to give me the number. If you plug 11 in here, what do you get? 11 times 11, which is 11 squared. You don't have to figure out, it's 121, but it's okay. I mean, those are the same entities. Make sense? All right, that was example 9 in your book. Let's do example 10. They didn't give us that on the slide set either. So here's example 10. 3n squared minus 5n is equal to 0. What do you do? Factor out the n. You've got the 0 there. Factor. What does that give you? N times 3n minus 5 equals 0. Now what do you do? Either n equals 0 or 3n minus 5 equals 0. We're beginning to like this better all the time, aren't we? What do you do with that one? Add 5 to both sides. You're trying to remember what the goal is. Isolate the n. Once you get it down to a linear equation, exponent of 1, isolate that variable. Okay? Add 5 to both sides. What does that give us? 3n is equal to 5. Now what do we do? Divide by 3. You want to isolate the n. And what does that give us? N is equal to 5/3. Oh no, you can't have fractional answers, can you? Of course you can. Decimal answers, radical answers, yeah, any kind of answer will work. Okay, unfortunately this is going to be a little messier, but we can do it. Plug in a 0. Not bad at all. What do you get? 0 minus 0 is 0. Got it. Y'all are a bunch of zeros. No. All right, let's try this one. What is 5/3 squared? Say again?
I said 5/3 squared.
What is it? Okay, yeah, I think we're going to have to do a little more than that on this one. 5 squared is 25. 3 squared is? So that would be 25/9. But you got a 3 out here. 3 will go in the 9. 3 times you get 25/3, right? And over here you get minus 5 times 5/3. So what will that give you? Negative 25/3. 25/3 minus 25/3, 0. That works too. You need me to write that out?
Yeah.
Okay. All right. These are a lot more fun. Sometimes checking's harder than just leaving to chance, okay? But I always like to check. So 3 times 5/3, that's what n is. That's what it told you here. Squared. That's a pretty ugly 5, isn't it? Let me see if I can make that 5 a little bit better. Okay. Well, wait a minute. This is such a pain in the neck. I just lost the screen. Previous. Not going anywhere. Yeah. Okay, let's go back to the white screen. really enjoy this. Okay. All right. What we had was 5n squared. Tell me if I'm right or not. 3n squared, okay. It was just checking to see if you're paying attention, okay? All right. 3n squared. I know I've got the pen. Okay. Okay, it was 3n squared plus, minus, which? Minus 5n. Oh, it's in the book. Why don't I look there? Clever. Okay. Equals 0. Okay. And we had n equal 5/3. That's what we're trying to check. So we do 3 times 5/3 squared minus 5 times 5/3 equals 0. Right? That's what you do. This was the problem. There was our proposed solution. What we're trying to do is see if that's right. So everywhere you see an n, plug in a 5/3 and do whatever it says to it. Okay? And this is 3. And let's go back. I like the way you were going to do it before. Let's do 5/3 as 5/3 times 5/3. That's what we mean by 5/3 squared, right? Okay. Minus, and this one we can just go on and do 5 times 5/3. Let's leave it like that. Equal to 0. Okay. Now, what happens if you divide out a 3 here? What do you have? 25/3 minus 25/3 is equal to 0. And sure enough, that's true. Now, that's one way to do it. That's not how I did it to begin with. But if you're going to write it out anyway, I'll do it that way. Okay? I was trying to do it in my head. I could see that in my head, but I couldn't figure out a way to get you to see it. Does that make sense? Or are y'all confused about that? Huh? Okay, you want to do it the other way. All right, let's do it this way. 3 times, what's 5/3 squared? 25 over 9 minus 5 times 5/3 equals 0. Okay? Now we'll do 3, we'll divide into 9 how many times? 3 times, and what does that give you? 25/3 minus, now when you're multiplying fractional forms, put that over 1, multiply the numerators, 25 over 1 times 3 is 3. And that's equal to 0. Is that better? No? What's unclear about it? Where am I losing you? Okay.
I got a question for you.
Yeah.
On the right hand side, when you cancel out, when you did the 3 and the 9.
Right.
What made you do that? Do it to the denominator and not do it to the numerator. What made you do that?
Okay, no. Okay. The simple answer is I'm lazy. Okay? Okay. I didn't want to multiply 3 times 75, 3 times 25 and get 75 over 9 and then have to reduce that. Which I would do. I would divide 3 into both of those. Okay? And just to be lazy and skip a step, again, this is 3 over 1, right? All right? Now, and this is what I was trying to show before. If you factored this term right here, you would have 3 times 5 times 5 divided by 9 would be 1 is just 1. 3 times 3, right? Okay? 3 over 3 is 1. Okay? And that leaves you 25/3. Okay? Does that make it clear? No. Okay. All right. Did you follow from what we had before? I lost the screen. That n is equal to 5/3. Were you okay with that? Okay. Okay. I want to know is where you got confused, and let's go there and straighten it out. Okay. All right. Let's see if maybe another example will help. I don't know if it will or not. You think it might? Okay. All right. Well, let's go to the next one, which I have to remember how we do that now. Pointer options, erase all ink from the slide. It won't do that. So what I have to do is screen option. This is unbelievable. I have to unwhite the screen and then white the screen again. Isn't that an efficient way to do it? Ah. Okay, number 11. All right. 3ax squared plus bx is equal to 0. And it says solve this for x. In other words, what we want to do is isolate the x. Okay? How would you proceed? Factor. Okay? And what's the greatest common factor of anything and all those factors? X. Okay? And what does that leave us with? 3ax plus b. And that product now is equal to 0. That makes sense? Okay, good. All right. Now, the second thing that we do, the next thing we do, once you have a product equal to 0, what do we do with it? Only way that can happen, two things multiplied together equals 0. One of them's got to be 0. Got to be. Okay, so we get either that. Here's one thing. Either x equals 0 or the other thing. 3. Okay. All right. That's what we were doing before. Okay. You factored this. You said you got it, right? Now, this says there's a product of two entities. X times this. That's what this parentheses, thing written right over parentheses, multiply. It means this times that is equal to 0. Now, can you give me any two numbers that these could represent that you multiply them together and get 0? The only way you can do it, one of those numbers has to be 0. 7 times 3 can't be 0. 7 times 1/7 is 1. It's not 0. Try every combination you can on the planet. The only way you can get a product of 0 is one of those two numbers have to be 0. That's the magic of 0, okay? In fact, 0 seems like a nothing, doesn't it? It's one of the most powerful numbers in our number system. You know, it's just an incredible little number there, okay? So either this is 0 or that's 0. Got to be to get a product of 0. And this is what this is telling you. So if this one's 0, there's a solution. X equals 0, plug it in. That becomes 0, that becomes 0, 0 equals 0 is 0. Okay? So that one's easy. I like that one. Okay? The other one, though, is a little more difficult, but not bad. The other entity is 3ax plus b. If that one's not 0, then this one has to be 0. One or the other has to be 0. That's why the or is in there. All right, now what we're doing now is solving for x. Now we want to isolate the x there. In other words, have a naked x on the left side and everything else on the right side. Okay? So how are we going to do that? Start by subtracting b from both sides, and that gives us 3ax, that goes to 0, is equal to negative b. What we want is to isolate the x. So we divide both sides by 3a. Okay? And these go away now. 3 over 3a is 1. So that gives you x is equal to minus b over 3a. Those are our answers. Okay? That's all you really have to worry about. I was just showing you before how to check this to convince yourself you had the right answer. You don't have to check it. That's not part of the problem. This is your solution.
or what you're proposing in the solution, all checking does is verify whether it's right or not. So if you get confused doing that, you can cross your finger, hope it's right, and go on, okay? Especially if you're under time pressure. Sometimes you don't have time to check. We've already checked this one. When you put a 0 in here, 0 times 0 is 0. 3a times 0 is 0. Put a 0 in here. You got b times 0 is 0. 0 plus 0 is 0. Okay, we got that one, right? The next one's going to be a little more fun. So let's do it, okay?
Instead of x, we're going to put minus b over 3a. So this comes down as a 3a times minus b over 3a squared, right? That's what your x was. You got to square it. Plus b times minus b over 3a. Supposedly, that's equal to 0. We don't know. We want it to be. Let's see if it is. You don't have to do this, remember, but it just verifies whether your answer is right or not. Okay? Now, you're multiplying here. Yeah. These are your answers right here. What we're doing now is checking to see if your answers are right. You don't have to do this. This is completely optional. If you're a little anal retentive like me, you might say, I want to make sure I'm right, okay? So here's how you do this. And there's several ways to do it, okay? I think the easiest way is to then write this as minus b over 3a times minus b over 3a, right? That's what minus b over 3a squared means, multiplied by itself. Plus b times a minus b over 3a. Is that equal to 0? That's our question. That's what we're trying to see. Okay? Now, these are three things multiplied together. Let's first deal with the signs. What's minus times minus? Plus. Okay? So we can lose the sign there. Minus times minus is plus. Okay? This 3a can divide out one of those 3a's. Right? So this then produces minus times minus is plus, so that would be your numerator is b times b, which is b squared. Your denominator is 3a. Okay? Over here on this one, minus times plus times minus is minus b times b is b squared over 3a. And sure enough, that does equal. Okay? You just verified that indeed is a solution. Okay? It really doesn't matter what those values are, as long as, this is further in the class, but what can a never be? Ever. What can you never do? Divide by 0. You can never, ever, ever divide by 0. So all this is telling you a can't be 0. The a and b can be any other numbers in the world. B could be 0, no sweat. That gives you the same answer as here. But a could be any other number in the world except 0. But of course, if a were equal to 0, this whole term would be 0, right? You'd have bx equals 0. Divide by b, as long as b is not 0, then x equals 0. You only have one solution then. So, introducing this term in it requires you a not to be 0. Okay, but that's a different issue. Don't get bogged down with that. Okay, I just threw that out there. We'll run into it later, but don't sweat it. Okay, any questions on that? This is so strange to have to do it this way. Unwhite the screen. Okay, here we go back. And we're ready for, we already did that and that. Okay, solving word problems that involve factoring. Oh, y'all been waiting for this, haven't you? Looking forward to these good old word problems because this is what really makes it fun, okay? So here we've got example 9. In the book, it's example 12. Okay? The area of a square is 3 times its perimeter. There's a little bit of something I don't like about that sentence, but we'll get there in a minute. Find the length of a side of the square. What would be the first thing that you would do? Second? Okay, he's going to look at the answer in the book. I understood. Okay, 149. Okay. What is the first thing you do when you have a problem like this? Second? Okay, set it up. Okay, what's your first step in setting it up? I like that answer. Huh? Okay, he's already ready to go to work. Okay? In word problems, you can't always do it, but when you can, draw a picture. Because what's a picture worth? Thousands of words, okay? So draw a picture. What do you think I might want to draw a picture of here? A square, okay? I like squares. I'll tell you why. My younger brother was a little wild, okay? He thought I was way unwild, and I was, you know. So he had a nickname for me. L7. What do you take when you put an L and a 7 together? Okay, you think you have an evil mind. Okay, I'm going to watch you. Okay, so for most of my life, he's called me L, which is short for L7. L has nothing to do with my name, but that. So I like squares. I identify with squares. So here we have a square. Okay? Not that funny. Okay. The area of a square is 3 times its perimeter. We're going to get back to that in a minute. Let's go to the next sentence. Find the length of the side of the square. What are we looking for? The length of the side of the square. Okay? What do you want to call that? That's our unknown. You get to choose the variable. What do you want to call it? L? Oh, nice name. So let's write that down. Let, if I could write, L equal the length of a side of the, you don't have to write all this. Okay, of the square. Okay? Now, can I draw that anywhere on the picture? Where? Any one of those things. This is L, that's L, that's L, and that's L. What is it that makes a square a square? There's really 2 things. Every side is equal. So if one of those sides is L, every side is L. The other thing that makes it a square is right angles, exactly. You could have a bent over square, and that's called a rhombus. We're not going to have a rhombus, we're going to have a square. Okay, it doesn't matter, well, it matters a little bit to the problem. All right, now with our square drawn and the sides labeled, what is the area of that square? Does anyone know what the area of a square is? L times L. So this thing right here is L times L. Let me just write it as L squared, okay? Is, how do you translate is? Equal to. All right, we got an equation going here. 3 times its perimeter. Okay, I think I know what 3 is. Now, what's the perimeter of the square? Second? Add all the sides together. Let's start here. There's 1L, 2L, 3L, 4L. There's the perimeter of the square. But walk around the square. How far did you walk? 4L. 3 times its perimeter, which is 4L. Guess what? We have an equation. Can we do anything with it? Sure we can. What would you do? L squared is equal to what? 12L. Now what? Say that again. Okay, so yeah, we need, since you have an exponent of 2, we need to get everything on one side, 0 on the other side, so we're going to choose to subtract 12L from both sides. Okay, I thought maybe somebody would ask that. Troublemaker. Okay, no, okay. No, I'm just kidding. It's a good thought. It's a very good thought. We're going to do it in a minute. I was going to show that as an alternative, but we're trying to do it the way they want us, okay? What does this side, left-hand side, become? L squared minus 12L, and the right-hand side becomes equals 0. Now what would you do? Yeah, divided Li. L divided times, that's factoring it out. What's left? L minus 12, okay, is equal to 0. Now, what can we say about that equation? Either L is equal to 0 or L minus 12 is equal to 0. Now, L equals 0. How many squares have you ever seen with the length 0? None. You can't see it because it has no length. So it's not really much of a square. So in this case, in word problems, sometimes we'll have extraneous solutions, meaningless solutions. That doesn't mean much. A length of a square can't be 0. That doesn't have any area. Well, everything fits, but it's just not much of a square. But this other one will give us the answer. What will that be? Yeah, add 12 to both sides, and that gives us L, that goes to 0, is equal to 12. All right. Now, let's see if that solves the problem. The area of the square, what would be the area of the square with length equal 12? What is this? L was 12. All of those L's were 12. Say again? 144. So the area would be 144, and that would be square units, whatever your units is. Is that equal to 3 times the perimeter? Well, what's the perimeter of that square if every one of those is 12? Say again? The perimeter would be? Walk around, how much you got? 48? Is that what you said? 48. So let's do the math and see what we get. 3 times 8 is 24. 3 times 144, isn't it? Sure enough, that's right. I said I didn't like the problem because that's not quite true. As I just said, these are lengths. They would be measured in inches, feet, yards, miles, furlongs, meters, centimeters, whatever. They'd be measured in something. The area of a square would be square units, like square feet, and this would be feet. So no, the area can't be equal. Numerically equal. If they put that word in there, numerically equal to 3 times its perimeter, I like the problem. They left off that because these have to be dimension quantity. It's really not a true statement. This will be in square feet or square inches. That will be in feet or inches or meters or whatever. But they're not equal, but they're numerically equal, which is fine. That's just a picky point. Okay. Any questions on that? Okay. What's that? The answer is 12, whatever units they are. Length of 12. Okay? Because you can't have a length of 0. That's not much of a square. Okay. Finally. All right. Nope, that's not what I wanted to do. Erase all the ink on the slide. Okay. All right. Let's see how they do it. Oh, they drew a square, didn't they? Silly them, they called it S. It doesn't matter what you call it. Okay? You can call it Fred. Okay? The S represents the length of the side of the square, and because it's a square, all those S's are the same. Then the sentence tells you the area is represented by S squared. S times S is S squared. The perimeter is 4 times S. Walk around there and you get 4 S's. Okay? So then we take that sentence at the top and write that down. S squared is equal to 3 times perimeter 4S. Exactly what we got, except we used L. It doesn't matter. And how do we go about solving that? S squared is equal to 12S. We subtract 12S from both sides, and then we factor it. S times S minus 12 equals 0. Either S is equal to 0 or 12 is equal to 0. If S is equal to 0, that's not a reasonable solution. It's not a square. Okay? It's nothing. There's no side length. So it must be a 12 by 12 square. And sure enough, that works. Now, going back to, I can't remember your name now.
Huh? Curtis. He said, why don't you, at this point right here, divide out an S? Right? And guess what? If you do that, you get S equal 12. Okay? A lot fewer steps, except for one thing. Now, this problem, you couldn't do it anyway. But you can't do that in all problems because, see, one of your solutions was S equals 0. And what would happen if you try to divide by 0? You can't do it! Okay? You never can divide by 0. In this problem, that was a meaningless answer, so you could do it and you got the right answer. But don't bank on that always being true. Because if this was your problem there, rather than it being a square, and it just says solve that thing, you have to give both answers. With it being a square, you can throw that one out. If you divide it by S, you get S equal 12. You give me one answer, there are really two, you get partial credit, but not full credit. So that's the danger of dividing out. Because you could be dividing by 0, or you could be dividing by something that's important that you'll need later. Okay? So, in this problem, it works perfectly. How much do you want to gamble? Okay? That it would on every problem. It probably won't. Okay? Now, that was example 12. Okay? Let's do example 13 in your book. Have to go to a white screen again. Okay. Suppose that the volume of a right circular cylinder, I'm abbreviating like crazy, is, now this time they said it right, numerically equal to, they said it right, equal to the total surface area I see the natives are getting restless. We're not running out of time, are we? What? Oh, no. You can't mean it. It's not a what? Oh, we've got 8 minutes. Okay. Getting me worried here. Okay. Is numerically equal to the surface area of the cylinder. We're not going to finish it, I don't think. That's the D there. Cylinder. Okay? If the height, okay, of the cylinder is equal to, this is ugly, isn't it? Okay. It's not that funny. Okay. To the length of the radius, okay, of the base, find the height. There's our problem. How would you begin? Say again? Draw a picture. Thank you. Okay. How do I draw this? What is a right circular cylinder? Ah, it's a tin can, okay? Make sense? It has a circular base, and it's supposed to be a right angle here, and this, and that. Is that a Yeti, or something like a Yeti? Okay. Could I handle it just a second? Okay. Okay. Cut off this, and you have pretty much a right circular cylinder. Or cut off that, and you have pretty much a right circle. It's tapering a little bit. This doesn't taper much. That's a right circle cylinder. My wife has one too. I don't. Okay. And she got one from her mom. This keeps ice all day long. Okay. Yeah. All right. Now, all right. So there's our right circular cylinder. Now, let's read through the problem. We're going to get to the volume in a minute. Is numerically equal to the total surface area. We'll get there in a minute. If the height of the cylinder, we need that. What in the world is the height of the cylinder? How tall it is. So that right there is going to be your height. You want to call it H? I'm in a hurry because we're running out of time. Okay, is equal to the
radius of the base. What do we mean by that? Yeah, the base is a circle. So if you take that circle and draw any line from the center to the outer part, that's a radius. Okay? Now, obviously, I haven't drawn my picture very well, have I? Because it's supposed to be the height's equal to the radius. Lousy picture, huh? It's what? You get it. Okay, I thought y'all were quick enough and sharp enough you could get it. Okay. So, we've got right here a real key thing. If the height of the cylinder is equal to the base, the radius of the base, h is equal to r. We've got a sentence right there. You see it? Height of the cylinder h is equal to the length of the radius r. Got it. Okay. Now we want to find the height. Now we got to go and find the volume of that right circular cylinder. Does anyone know what the volume of any regular object is? Excellent. Okay. The answer I was looking for, that was more precise, was the area of the base times the height. And the area of the base is pi r squared. So we have the volume here. Volume is pi r squared h. Pi r squared is the base, area of the base, height is the height. Okay? There we have that. Now, how about the area, the surface area of the cylinder? If you can, from my ugly picture, tell me what would be the surface area of that cylinder. What? Okay, surface area. Okay. You already gave me the area of the base, pi r squared, but you got a top and a bottom. So you got 2 pi r squared, right? That's part of the area. And then, okay, we're going, oh, goodness gracious, you're ahead. Okay. So there's 2 parts of the area. Okay. The area is the top and the bottom. And we've already said each of those is pi r squared. This is pi r squared. This is the area. Okay. This is the area of the bottom. This is the area of the top. Okay. So we've got, okay. You're getting right there. Okay. Now what we're going to do is take some scissors or shears or something and cut up the side of that can. We're going to destroy the can. And then we're going to fold it out. All right? That's what you were thinking. Okay? Now, when you fold it out, what kind of a shape do you have? You have a rectangle. And what's that? Yes, exactly. Okay? That's why I said shears, because if it's a tin can, scissors won't work. Okay. So, this was your h, height there. What was this dimension here in this picture here? That's your circumference of the circle. Does anyone know what the circumference of a circle is? 2r times pi. 2 pi r or pi d, diameter times pi. That's the circumference of a circle. Now, if you don't know these answers, you got the front of your book here, okay? And there you have a circle here. The area is pi r squared. The circumference is 2 pi r. It's right there in the front of the book. But I wondered if y'all knew it. So here we have 2 pi r is the circumference of the circle. That's a rectangle. What's the area of a rectangle? Length times width. So the area of the, I'll call it rectangles, the surface, that is 2 pi r h. Okay? Now what our sentence up here said, the volume of the right circular cylinder is numerically equal to the total surface area of the cylinder. Well, here was the volume. The total surface area is 2 pi r squared plus 2 pi r h, because it was top and bottom and the sides. Okay? Now, if those are numerically equal to each other, and the other little key here is r is equal to h. So everywhere you see an r, put an h. Pi h squared times h is equal to 2 pi h squared plus 2 pi h times h. And that gets to be a pretty simple equation. Pi r, or h cubed is equal to 4 pi h squared. Okay? And I think we're out of time, aren't we? Oh, shucks. That's so sad that happens. Okay. Now, if y'all can remember where we left off here, solving this problem's a piece of cake from here on. In fact, can you do it on your own, or you want me to come back to it first thing next time? Huh? Come back to it. So y'all remember where we are here. We won't want to do this all over again, but we can do it. All right, good deal. Sadly enough, wait. Let me give you some homework exercises. Any of the odds, 1 or 3, any of the odds 5 through 41.
On what page?
Yes, it's on page 150 and 151. Any of the odds 43 through 63, any of the odds 65 through 79, any of the odds 81 to 85, and then any of the odds 87 to 95. Good deal. I would hate for you to have all weekend and nothing to work on. So, okay, I'll say it again. Either 1 or 3. Any of the odds 5 through 41. Okay, any of the odds 43 to 63. Any of the odds 65 to 79. Any of the odds 81 to 85. And any of the odds 87 to 95. Okay? 5 through 41. Any of the odds 5 through 41. Any of them. What the deal is for you to do as many as it takes so you feel comfortable you know how to do that. Huh? Okay, if you pick the hardest one in the section, you can do it, move on to the next one. Exactly. If the easy ones give you problems, practice on more of them. This is up to you, okay? Okay, I thought you were. Okay. Good deal. And we'll pick up then and wrap up that little bit we have to do with example 13. It's not much. It's
been years, but the college calculus.
Oh, okay.
It's been years.
Okay. Well, you seem to have it down pretty well. Thank you.
You did get my syllabus in the email, right?
I saw that you did it. I haven't printed it because I was at home and not on the printer. So I'll print it when I have a chance in office. Yes, ma'am. Have fun. A tutor? Okay. If you go right down the hall here, in fact, let's just go out there and see. Do you have a question?
If you show me the best way to evaluate this out.
Okay. Okay. Let me get her taken care of. Yeah. Okay. Let me show you what the tutor. Okay.
How you doing?
I'm doing all right. How about yourself?
Pretty good.
Catching on pretty good?
Well, I'm trying to. I got some questions about factors and stuff. The equation stuff, I got it, I think. I'm practicing it. But the factors stuff, I didn't get it too well.
Okay. What about the last part right there?
No.
The word problem. You know what I'm saying? The word problem, the bullet. Yeah. Well, good luck to you, man.
All right. You have a good day.
I wanted to point out to her where to go.
I got the equation stuff you went over today. I'm just gonna take the practice, but I think I've got it. But the thing I'm having problems is when I was looking at the homework assignment this scientist, I was having problems with the second variable, how to factor out completely.
Is that
Six
X
X.
also?
It's a Y.
No, oh yeah, okay, if that's a Y, then how you can factor this, the only thing common to those two terms is what?
3.
3. So factor out the 3. We can divide by, okay, you write down the 3, okay, equal, put the equal sign here, okay, write down the 3, okay, no, let's do, okay, yeah, just, okay, no, okay, no, I'm sorry, I'm not very clear, okay, this thing is equal to, you're factoring out a 3, meaning you're dividing the 3 out of the rest. What's left over if you pull the 3 out of 6x?
3x.
No, you're dividing.
Okay. It'd be a 2.
2x. Okay, 2x. And if you divide a 3 out of 3y, you get into the plus. So the plus sign there. Okay.
If I 3 out of 3y, it's gonna be y.
That's just going to be y.
That's it.
You just done it. I wish I could make it harder, but I can't figure out a way to do it.
And now we got this ends with the number right here, so what would be the best way to do it the same way?
Put an equal sign. Okay. Sorry about that. All right. Now, what's the, go put the parentheses yet. Okay. What's the greatest common factor you see between those two numbers?
6. You gotta go.
6 won't go into 14.
Gotta go in both of them.
Yeah.
2.
2. So write down the 2. Okay. What else? Oh, don't put parentheses yet. Okay, that's the number part. How about variables? X. So factor out a 2 and an x. Okay, 2x. And then put your parentheses. Okay. Now what's left when you factor out 6x squared when you divide out a 2?
That's gonna be
3. So put down the 3. And what's left with x squared when you pull out an x?
just squared.
X, exactly. Because x squared means x times x. And you take one number out, you have x. Okay? Then put your plus sign. Okay? And what's left from 14 if you divide out of 2?
7.
7.
If you divide the x, it goes 0.
No, it goes 1, yeah. So yeah, close parentheses, you got it. Perfect.
Looks pretty simple.
Yeah.
This is an extra variable, so that confused me. I was looking
Yeah,
at the examples
yeah.
in the books, and they was all, none of them had a number. I just see one like that, and I was like,
Yeah.
confused.
Yeah, if you don't have a number, it's a variable. It's standing in place.
It's just something I had to practice. It's just
Yeah.
gonna take a lot of practice. You know, that's how
Yeah,
math is.
that's it.
Very
That's why I
easy.
give you all those homework, do as many of them as take, but once you say, hey, I got this, we won't do the next one.
I still have to work on this one.
Yeah, well, this is
It's a little bit more complicated problem, but I wanted to show you even a complicated problem can be broken down out. Remind me to do this one next time. How do you eat a 5,000 pound elephant?
A little bit at a time.
One bite at a time, exactly. And that's how you do math. One step at a time. It is.
I'm getting to do it for this class. I ain't got it yet. Student services. She said she had one for me, and he was a really intelligent guy to help me out with some of this stuff, but she hadn't assigned it to me yet, so I don't know when I'm gonna be getting it. That's why I'm trying to. That's why I'm staying here asking you questions.
Okay.
Trying to make sure I'm getting it.
Okay, and what don't you have yet, you said?
Sir, this is.
Oh, just this. Okay, I thought you meant the book. Okay.
I got my book. I just don't have my tutor yet.
Tutor yet. Okay, that's what you said. My hearing's so bad.
Well, assigned that tutor, man.